This lesson for pre-calculus is on solving trig equations. It is super important and a very foundational concept for pre-cal and calculus. So take your time going through this video, pause when you need to, make sure you're digesting everything and understanding the why behind what we're doing today. So that this sticks with you, because like I said, this is very important. Okay, so you can see in the top right corner I have a copy picture of the unit circle, which we're going to be using. So it's just there for reference, but hopefully it's sort of engraved in your head. So in looking at examples 1, 2, and 3, our job is to solve this equation for x. Okay, so the biggest thing I want you to understand is that x is a part of a trig. So if I were to read number 1, instead of saying 2 sine x minus 1 equals 0, focus on the fact that it's 2 sine of x minus 1 equals 0. That's not sine times x. That's sine of x. And x is some angle. So my goal is to find an angle. So I'm going to take this first equation, and the first thing I'm going to try to do is isolate the trig. So I'm going to add the 1 and then divide by the 2. So I have sine of x equals 1/2. Now, you could go to your calculator and do sine inverse 1/2, and that would give you the x. Remember, when you don't have the angle, you can sine inverse the answer and it will give you the angle. But for today, I don't want decimals. I want you to use your unit circle. So what this is asking is, what angle? So that when I take sine of that angle, I get a 1/2. So I need to look on my unit circle for where sine of some place is a positive 1/2. And that's going to happen there and there. So those are the only two places on my unit circle where sine of that particular angle, or any angle in that unit circle, is a positive 1/2. So now I want to know what angles make that happen, and I want it in terms of radians. I don't want degrees. So this first one is pi over 6. So x equals pi over 6, and this one is 5 pi over 6. So x, which is an angle, has two answers, pi over 6 and 5 pi over 6, where when I sine that angle, I get a 1/2. Okay? So number 2, and kind of using your algebra skills, you want to get your trig together and your non-trig on the other side. So I'm going to add this sine x over. So that gives me 2 sine x. And then I'm going to subtract that root 2 over and get negative root 2. And then I'm going to divide both sides by 2. Okay, so now I want to go to my unit circle and I want to find sine of some angle that equals a negative root 2 over 2. Well, now remember, sine is your y value. And if this y is negative, then I know I need to be looking south of the border. So I'm looking in quadrant 3 or quadrant 4. And the root 2 over 2, remember that came from our 45s. So I know it's going to happen here and here. So x is going to equal 5 pi over 4 and 7 pi over 4. Okay, number 3, I'm going to subtract the 2. Okay, now cosecant doesn't live kind of out in the open on our unit circle, so I'm going to turn this cosecant into a sine. Okay, now watch what I'm going to do. Cosecant is 1 over sine. Well, I don't want 1 over sine. I really just want sine. So if 1 over sine equals a -2, then sine of x equals a -1/2. So I challenge you to be able to do this. Take this middle term out. If I want to turn cosecant into a sine, then instead of flipping the sign, flip what it equals. You see if you can skip that step and go straight to it. So if I had secant of x equals 3, then cosine of x would equal 1/3. If I had tangent of x equals 5, then cotangent of x would equal 1/5. Okay, so I'm looking at this one. I want to know where sine is a -1/2, so sine is my y value and it's negative, so south of the border. And I want it to be pretty, so it's going to come from an ugly pretty. So that's going to be here or here. So x is going to equal 7 pi over 6 and 11 pi over 6. Okay, number 3. So first thing I'm going to do is isolate my trig. So I'm going to add my 1 and divide by 3. Okay, and then I need to get rid of the square. So I'm going to square root both sides. But you know that when you square root both sides, you have to put a plus or minus. And then I'm just going to clean that up. That's going to give me 1 over root 3. And then clean that up a little bit more. And that's root 3 over 3 once I rationalize the denominator. Tangent does not live out in the open on our unit circle. And this is why we spent so much time on the unit circle when we started. Tangent is going to equal root 3 over 3 either at ugly pretty or pretty ugly. So ugly pretty and pretty ugly. And I have to figure out which one is going to give me, when I put y over x, because that's what tangent is going to give me a root 3 over 3. So I'm going to start with my ugly pretty. So y over x, and then at Bojangles. And that gives me 1 over root 3. And when I multiply by root 3 over root 3, that's going to be the one I want. So this is my winner. If that one wouldn't work, I would go try this one. But I know it's not going to be my 45s because we know that tangent and cotangent of the 45s is either 1 or -1. And I know it's not from a north, south, east, west because tangent and cotangent there is either going to be 0 or undefined. Okay, now I want all the positive and the negative versions of a root 3 over 3, which means these guys, these pair of coordinates can either have the same sign and give me the positive, or they can have opposite signs and give me the negative, which means I want all 4 of them. So I want that guy and that guy. I want everybody that has the correct coordinates, but I don't care what the sign is because of that plus or minus. So x is going to equal pi over 6, 7 pi over 6, 5 pi over 6, and 11 pi over 6. And I'm sorry I went out of order a little bit there. Okay, and again, pause it if you need to pause it and go back and chew on that problem if you need to. Okay, number 5. Okay, well, we've been saying get all the trig on one side and get all your non-trig on the other. Okay, well, make sure you understand that this is one term and this is one term. You cannot divide by cotangent because that would make a cotangent completely go away. I need to get my trig on the same side. So I'm going to subtract the guy on the right over to the left. And now I'm going to do what sort of is like dividing, but it's not going to go away. I'm going to GCF a cotangent out. And that's going to give me cosine squared x minus 2. And then I'm going to pull them apart and set them each equal to 0. The first one's ready to go. The second one, I'm going to add 2. And then I'm going to root both sides, which means there's a plus or minus. Okay, so the first thing I'm doing is I'm looking for where cotangent is a 0. Okay, well, I'm going to go look at my unit circle. Cotangent is a 0. Now, cotangent is x over y. So for that to be 0, the top would have to be 0. Because if the bottom's 0, it's undefined. So I need to find where my x is 0. And that's going to be at north and south. So pi over 2 and 3 pi over 2. Okay. And then I'm going to come to this one over here, and I want to know where cosine is a root 2 or a negative root 2. And guys, there's nowhere on your unit circle where cosine is a plain root 2. I have root 2's over 3's, or root 3's over 2's. I have roots and I have 2's, but I don't have anything that's just a root 2. I have a root 2 over 2. But I don't have anything when it's a cosine, it's just a plain old root 2. So this gives me no solution from my unit circle. So the answers to this equation are just going to be him. Number 6 should kind of stand out as a trinomial. So if you need to algebraify, so that would be 2x and x and 1 and 1. I want a negative 1. So I want a negative 2x and a positive 1x. All right, and then if I put my trig back in here, and if you don't have to algebraify it, that's fine, that's great. Now I'm going to set them each equal to 0. And again, if this is going too fast, just pause it, go at your own pace. For this one, I'm going to subtract 1 and divide by 2. And for this one, I'm going to add 1. So I'm going to go on my unit circle, and I'm going to find where sine is a negative 1/2. So I'm going to give you a second and let you look at the unit circle and find where sine is a negative 1/2. So that would have to come from a ugly pretty. Negative 1/2 is going to be there and there. So the answers here are going to be 7 pi over 6 and 11 pi over 6. And then the second part of that one was sine x equals 1. So I need to know where the y value equals a positive 1. And that only happens in one place. And that's pi over 2. So the answers for this one are 7 pi over 6 and 11 pi over 6. And a pi over 2. Okay, now 7 sort of looks like it wants to be a trinomial. And I could subtract that 3 over and get it equal to 0. The problem with number 7 is I have 2 different trig functions. I have one that's a sine and one that's a cosine. Okay, but luckily you know that sine and cosine are related through the Pythagoreans. So you can take this sine squared x and think about what you can replace that with. Okay, so then I'm going to take that 2 and I'm going to distribute it through. I'm going to go ahead and subtract that 3 over. Then I'm going to kind of readjust and combine some like terms. 2 and the negative 3 gives me a negative 1. So now this is a trinomial. I do not like doing trinomials with a negative in the front. So you can think of this as 2 different things. You can take all 3 terms and move it to the other side. or you can run through with a -1, but either way it's going to change all my signs. So that's going to give me 2 cosine squared x minus 3 cosine x plus 1 equals 0. The equals 0 sort of absorbs that -1, or like I said, you can think about it like taking all 3 of these terms over to the other side. Okay, so now gonna factor. So 2 cosine x and a cosine x. And that would give me a 3 and a -3, so I need both these to be negative. So then I'm going to take both of these and set them equal to 0 and solve it. So I'm just going to kind of be quiet and give you guys 10 seconds to kind of start doing that. And then hop to your unit circle. And I need to know where cosine is a 1/2. So that would come from a pretty ugly. And pretty uglies are up here and down here, but it's x because it's cosine, and it's positive, so x would have to be positive. So it's this guy and this guy. And so those are my thirds. So x equals pi over 3, 3 thirds, 4 thirds, 5, and 5 pi over 3. And then where's cosine? 1. And so that would be east. Now be careful here. That's 2 values actually. It's a 0 and it's a 2 pi. Not pi. Pi is way over here. But this point right here is 0 and it's 2 pi. Okay. Last one of these before we kind of tweak things a little bit. Number 8. Again, I've got 2 different trig functions. So on the last problem, we used the Pythagoreans to kind of replace and get them all in terms of the same trig function. The problem on number 8 is nobody's squared. So I can't use my Pythagoreans. They're already in terms of sine and cosine. So I'm trying to run through my bag of tricks and think of anything that I can use to kind of give this a little bit more meat to it. And again, the problem with not being able to use the Pythagoreans is nobody's squared. So what I'm going to do is I'm going to square both sides of this equation. So be very careful in doing this. Make sure you are algebraically sound when you do this. Let me erase this so I have a little bit more room. I'm going to square both sides, and that's legal because I'm doing it to both sides. Now, on the right-hand side, we're just going to have sine squared, which is great. And on the left-hand side, a lot of people mess this up because they're just going to write cosine squared plus 1 because they square the cosine and they square the 1. But when you square something that has more than one term, technically you have to write this twice because that's what square means. And when you multiply those two things, that's a lobster. That's a foil. So that's a cosine squared x plus 2 cosine x plus 1 equals sine squared x. Okay, well now this has a little bit more meat to it. I have a cosine squared and a sine squared, so I need to think about which one it would be better to replace. Well, I also sort of have this floating plain old cosine here. So, and I can't replace him. So I feel like I need to get everything in terms of cosine because I'm not going to be able to change this guy. So I'm going to replace this with 1 minus cosine squared. So I'm going to give you a second to go ahead and replace him and then get everybody on the same side and kind of clean it up and then see where you stand. Okay, so once I replace and get everybody on the same side, the ones are going to cancel. So I'm here. This is not a trinomial, but I can GCF. I'm going to take a 2 just because I can, and then take a cosine x. And that leaves me with cosine x plus 1. And then I'm going to set each one of these equal to 0. This one I'm going to divide both sides by 2. And this one I'm going to subtract 1. So now I need to think about my unit circle. And I want to know where cosine is 0. Okay, well cosine is the x value, and x value is going to be 0 at north and south. So that's pi over 2 and 3 pi over 2. And cosine, again, which is x value, is going to be a negative 1. That's going to be way over here at pi. So he has 3 solutions. Okay. Now number 9, number 10, and number 11, well, 9 and 10. 9 and 10 are different because their ofs have a little extra something special in them. Number 9, that's 2 cosine of 3x minus 1 equals 0. So the of has this extra 3 in there. Okay, so for right now, we're going to completely live in denial and pretend that's not there. I'm going to add the 1 and divide by 2. I'm going to isolate my trig. So cosine of 3x equals 1/2. The number one mistake people make right here is they'll say, oh, well, I'll just now divide by 3. But that's not cosine times 3. That 3 is in the trig. It's cosine of 3x. So what I want you to do is completely ignore the 3x, and I want you to find me where is cosine 1/2. But instead of letting that equal x, that's going to equal 3x. Then once I get those places, I take those places and I divide them by 3. So I want to know where cosine is 1/2. Okay, so if I think about my unit circle, cosine is x. X is 1/2, so that's pretty ugly. So that's the top and the bottom, and it's positive. So it would have to be this one, which is pi over 3, and this one down here, which is 5 pi over 3. So instead of having x equal these places, now I just have 3x equal to these places. So now to finish solving the equation, I just divide them by 3. Well, to divide by 3, just slap a 3 on the bottom. So that's pi over 9 and 5 pi over 9. So when your of is jacked up, just completely ignore it at the beginning, solve it like normal, set your jacked up of equal to the places on your unit circle, and then solve the of. Okay, let's try another one. So number 10. Okay, so the first thing I'm going to do, the of is definitely jacked up, but the first thing I'm going to do is isolate my trig. So I'm going to subtract 3, and then I'm going to divide by 3. So that's going to give me tangent of x over 2 equals a negative 1. So I'm going to completely ignore this, and I just want to find where is tangent negative 1. Well, I know that tangent is y over x. So for it to equal 1, my y's and x has to be the same. And that happens at my 45's. But it's negative, which means the signs need to be different, which means it's that one or that one. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. Okay? So I found where tangent equals a negative 1. Now I'm going to deal with my of. Well, to solve for x, I wouldn't divide by 2. I would multiply by 2. So I'm going to multiply everybody by 2. So x equals, now remember this is 2 over 1, not 2 over 2. So don't multiply the top and the bottom by 2. So that would be 6/4, which is 3/2. And that would be 14/4, which is 7/2. Okay. Let's see, the very last one goes back to normal ofs. I do have two different trig functions, so that's not ideal, but one of them is squared and they are related in the Pythagoreans. So I'm going to take this dude right here and replace him with 1 plus tangent squared. So now I'm going to kind of rearrange them, put them in order, and I'm going to subtract that 4 over here. So I'm going to have tangent squared x minus 2 tangent x. And if I subtract the 4, that's going to be a negative 3. Now make sure that you're good with the fact that before we were separating the trig and the numbers because everything was linear, but when it's quadratic, you want to get it equal to 0 because you're going to factor it. And then this is just a nice trinomial. Three and a 1. I want a negative 2, so a negative 3 and a positive 1. Set them both equal to 0. And again, feel free to pause this and go at your own pace. So tangent x equals 3 and tangent x equals negative 1. Okay, remember that tangent is y over x. So I need, where is y over x a 3? Well, guys, that's not going to happen at your north, south, east, west because tangent there is going to be 0 undefined. It's not going to happen at your 45s because tangent there is either a 1 or a negative 1. We did the tangent of this guy, and I think he was root 3 over 3. If I do the tangent of this guy, it's got a root 2 in it. The point is it's not going to be a 3. Nowhere on my unit circle am I going to get a tangent that's a plain 3. So that gives me no solutions. I can have a tangent that's a negative 1. That's going to happen at my 45s because that's where my x's and my y's are the same. But it is a negative 1, so I know my signs are going to be different. So that's this guy and this guy. So x equals 3 pi over 4 and 7 pi over 4. Okay, so again, I hope you take your time going through this video. Feel free to go back and just watch it now that you've taken the notes, and then dive in and do the homework, and come see me if you have any questions. But remember how important this is and how foundational this is, not only for pre-calculus, but also for calculus.